Hello, welcome to Pragim Technologies. I'm Venkat. This is part 42, Custom Exceptions. In this session, we will learn when to create custom exceptions, creating a custom exception from the scratch, throwing and catching the custom exception that we create. Now, to understand custom exceptions properly, you should already have a good understanding of inheritance, exception handling basics, and inner exceptions. If you want to learn more about these concepts, please watch parts 21, 40, and 41 of this video series. Now, when do you usually go for creating your own custom exceptions? Why is there a need to do so? Because if you look at .NET itself, .NET provides us with so many exceptions. We have file not found exception, index out of range exception. .NET provides us with so many exceptions. So what is the need for us to create our own custom exception? That's what we'll answer in a bit. But to find out all the exceptions that are already available within the .NET framework, what you can do is you can go to the debug menu and select exceptions button. This window will show you all the available .NET exceptions already. And to get to this window, another keyboard shortcut is Alt Control E. For example, we know that if we are trying to read from a file and if the file is not found, we usually throw a file not found exception. So if I want to find that file not found exception, go to Common Language Runtime Exceptions, and we know that any classes to do with system IO are present in system.io namespace. So if you see here system.io.file not found exception. Okay, so similarly there are so many exceptions within the .NET framework. Now there might be scenarios where one of these exceptions that are already available may not be adequate enough to describe the problem that I have. Let's look at an example. Now let's say I have an ASP.NET web application, and the requirement of this application is such that it should only allow us to log in one time in a browser window. If I am already logged in a browser window, and if I try to open another browser window, and if I try to again log in there, it should throw an error message saying you are already logged in. And to serve this purpose and to describe this problem adequately enough, we don't have any exception that's already available within the .NET framework. So this could be one of the classical examples when you want to design your own custom exception. Okay, and to do that we have certain steps, and it's very easy to do that. Okay, so let's look at step by step of creating our own custom exception. Okay, so to create a custom exception, and we know that an exception is nothing but a class. For example, if you look at the exception class itself, it's a class by itself. Okay, and we know that all exceptions within the .NET framework directly or indirectly inherit from the system.exception class. So system.exception class is the base class for all other exceptions that are already available within a .NET framework. Now, if you want to create your own custom exception class, and if you want all the features that an exception object having, then you make your custom exception class inherit from that base exception class. This way you don't have to provide any of that functionality. You inherit all that functionality from the basic exception class. That's why when you're creating your own exception class, the first step in doing so is to create a class that inherit from the exception class. So public class, and we want to name our class as user already logged in, and we want to make this class inherit from the exception base class. Okay, now you know that we know that we have file not found exception, for example. Look at that. And file not found exception, by the way, it's in the system namespace, so we have to import that. So system.io, and now if I try to look at the file not found exception, for example. So file not found exception, if you look at this file not found exception, or index out of range exception. So all the exceptions basically end with this suffix exception. Okay, so what's the advantage of that? Basically, just by looking at the name of the class, you can say, okay, this is an exception class. Okay, so even your exceptions, if I say user already logged in, okay, is this a regular class or an exception class? So just to identify, to differentiate that we can, it's a common convention to actually end your class name with the exception suffix. This way, by looking at the name of the class, you can say, okay, this is an exception class, just like file not found exception, or index out of range exception, or invalid operation exception, user already logged in exception. Okay, so follow that convention. Even if you don't do that, if you omit this exception, you don't get any compile time error, but you're slightly deviating from the design guidelines of creating a custom exception class. All right. So, to create your custom class, at the minimum, this is what you have to do. You're done creating your custom exception class. Okay. Now, let's say, for example, if you want to throw a file not found exception, how do you do that? You use the throw keyword. Throw new file not found exception. Okay. Similarly, now let's go ahead and run this fast. When we run this, what happens? We'll get that system.io.file not found exception. Okay. Now similarly, if you want to throw your own exception, what do? You say user already logged in exception, and when we run this, you get that exception. Okay. But the difference is, if you look at the file not found exception, if I want to customize the message that we show to the end user, I can do that by using one of the constructors. Okay, I can pass in a message to this file not found exception, and let's say, for example, file XYZ is not found. When you do this, what happens? This message will be shown, as part of that exception object. So file XYZ is not found. Now, is it possible to do that kind of a customization for my exception class? No. Because why? Your constructor does not, your exception class does not have any constructor. You didn't provide any constructor. If you don't provide a constructor, we know that .NET Runtime Environment automatically provides a default parameterless constructor. And that's the only one which is available now. So if you have to provide your class the flexibility of passing in a message so that the developer can customize the message they pass into your custom exception, then you have to provide that constructor. And to do that, it's pretty simple. Okay, let's finish this. All right, so public user already logged in, and to this I pass in the string parameter, and let's call that message. Now, if you look at the exception class, we know that the exception class also has, if you look at this now, our user already logged in exception, custom exception class is actually inheriting from the exception base class. Okay, so, and if you look at the exception base class, if you right click at that and say go to definition, if you look at the exception base class, it has a constructor which takes in a string parameter. So now all you have to do is invoke the base class constructor using the base keyword, and then invoke this overloaded version, passing in the message. So now what are we doing? We are communicating from the derived class to the base class, okay, using the base keyword. Okay, so now if you look at this one, we get a red squiggly here because once you provide a constructor to your class, the default parameterless constructor provided by .NET Framework is taken away. So if you also want users to be able to create just without passing any message, they should be able to create user logged in exception. If you want to provide that capability, then probably have another constructor which doesn't take any parameter. Now here we don't want. So what we are essentially doing here is constructor overloading. Again, we have covered that in a separate session. Please check that specific part on constructor overloading. Okay, now if you look at this constructor, it doesn't take any parameter. And in the exception base class, we already have a constructor which does not take any parameter. So from your derived class, just invoke that specific constructor. That's one of the overloaded base class constructors. Okay, so now what have you done until now? You have provided two constructors to your class. Okay, one which does not take parameter, one which takes a string parameter. Now if the user wants to customize the message, all they can do is, okay, user is logged in. no duplicate sessions allowed. You can basically customize it the way you want. Okay, so now if we run this, you should see that custom message. All right. Now, in part 41, we have learned about inner exceptions. What is the advantage of using inner exceptions? Inner exceptions basically allow us to track the original exception. Okay, so if you're not sure about inner exceptions, I would strongly encourage you to watch this part 41 before continuing with this session. So we know that inner exceptions basically allows us to track the original exceptions. Now, if you look at your class, it's not possible, for this exception to track the original exceptions. Okay, so if you want to provide that capability for your custom exception class, then you need to provide that overloaded version, okay, of constructor. If you look at the base class, it has got another constructor. If you look at this constructor, it takes in a message as well as another parameter of type exception. Okay, and basically this is the original exception, and you can pass that as a parameter. Okay, so let's go ahead and provide that constructor as well. So public user already logged in exception, so the first parameter is of type string and the next parameter is of type exception, and this one is going to be inner exception. And what you do here, you call the base class constructor passing in the message and inner exception. We have already seen that this base exception class has that constructor. So call that overloaded version of the base class constructor and pass in the respective parameters. So now we have provided another constructor as well. So now using your class, it's also possible to track inner exceptions. Okay, so if I try to go ahead and create an instance of this class, look at this, there are 3 overloaded versions now. You can see that in the IntelliSense here. All right. Now another important thing to keep in mind. Now this class, it works, but it only works within the same application domain. Now what's an application domain? We will talk about application domains when we talk about remoting web services and WCF. Okay, basically if there are 2 applications and they want to talk with each other, let's say for example I have application A1 and application A2. Now if I want application A1 to talk to application A2, then the objects that you create within application A1 has to cross the brown boundary of this A1 application and reach application A2 boundary. Now when you have to move objects across application boundaries, those objects need to be serializable. Okay, so we'll talk the concepts of serialization. Serialization is nothing but breaking down that object into packets that can be transmitted over the network. So if you want to move your object from one application domain to another application domain over the network, then the class has to be serializable. Okay, so if you want your custom exception class to be remotable or serializable, then the first thing that you have to do is to decorate this class with serializable attribute. And then if you look at the base exception class, the base exception class has an overloaded constructor for serialization purposes, which takes in serialization info. And if you look at the IntelliSense, the serialization info class is actually present in system.runtime.serialization namespace. Okay, so if we have to use that object, we have to import that namespace and then invoke this constructor from our class. So let's provide that. So first of all, let's go ahead and import system.runtime.serialization namespace, and then we need to provide a constructor for our class which supports serialization. So user already logged in. So if you look at the base class, what is the first parameter? It has to be serialization info, and the next parameter is of type streaming context. So serialization info, and let's call that as info, and the other one is streaming context, and let's call the object reference variable as context. And then what we need to do, we need to call the base exception class constructor, passing in these parameters, so info and streaming context. Alright, so our class at this point, our exception class, is almost equivalent to any other exception uh, class that's available within the .NET framework. You have provided all the overloaded constructor versions, which the end user can use for a variety of different purposes. And obviously, so if you want to call any of these constructors, it's possible. And if you want to handle this exception, so if we want to throw it, we throw it in the try block using the throw keyword. And to catch that, you can use, user already logged in exception, maybe EX and console.writeLine EX.message. And if you pass any inner exception, when you're throwing this, you can also track that inner exception. Look at this. If I say comma, you can actually see one of the overloaded constructors, taking in a string parameter, and the other parameter is of type inner exception. Okay. All right. So when we run this now, you should see only the message of that exception printed. Okay. So let's quickly review what we have seen so far. So creating custom exceptions, what are the steps? Create a class that derived from system.exception class and as a common naming convention, and the class name with exception suffix, because all .NET exceptions end with exception suffix. And if you want your exception class to conform to those standards, then name your class so. And we provide a public constructor that takes in a string parameter. So this constructor simply passes the string parameter to the base exception class. And what does this provide to us? It provides the flexibility for the user to pass in the message that they want into your exception class. And if you want to track inner exceptions, you basically have to provide that overloaded version of the constructor. And similarly, if you want your exception class to be working across application domains, then you need to mark your class as serializable. And remember that it is also possible to provide your own custom serialization. If you look at this example, we are using the default serialization that's provided by the base exception class by providing that constructor which supports that base class serialization. But on the other hand, it is also possible to provide your own custom serialization. So we'll be talking about serialization and customizing serialization in a later session in detail. That's it for today. Thank you for listening. Have a great day.